are going to discuss the last part of our chapter of chemical bonding. This is part 4th, and here we shall deal with polarity of molecules. When a covalent bond is formed between two atoms of same electronegativity, then the bond is said to be non-polar or 100% covalent. But if there is a difference of electronegativity between the bonded atoms, then the bond is said to be polar. More is the difference of electronegativity, more is the polarity of the bond. Thus, Cl bond in Cl2 molecule is non-polar, but HCl bond in HCl gas molecule is polar. A more electronegative atom will naturally attract the electron pair, say bond pair, more towards itself. Hence plus delta and minus delta poles are produced as shown above. Polarity of a covalent bond as well as that of entire molecule is expressed in terms of dipole moment. So let us now study dipole moment. Consider a polar covalent bond shown here, in which atom B is more negative than A, and the distance between the two poles be equal to x. This distance x is actually the distance between the centers of the oppositely charged poles, but in many cases bond length serves the purpose of x. Then the dipole moment of the above polar bond will be equal to delta into x. Thus, dipole moment is defined as the product of pole charge and distance between the poles. Unit of dipole moment. It is usually expressed in terms of d units, such that 1 dBi is equal to 10 to the power minus 10 ESU into 10 to the power minus 8 centimeter, and that's equal to 10 to the power minus 18 ESU into centimeter. But in SI system, it is expressed in terms of coulomb into meter. Since 1 coulomb is equal to 3 into 10 to the power 9 ESU, hence 1 dBi, that is 1 d, will be equal to 10 to the power minus 18 ESU into centimeter divided by 3 into 10 to the power 9 ESU. So it becomes in terms of coulombs multiplied by 10 to the power minus 2 meter. So 1 dBi becomes equal to 3.33 into 10 to the power minus 30 coulomb into meter. Well, direction of dipole moment. Conventionally, it is directed towards the more electronegative atom and is represented by the symbol as shown here. Resultant dipole moment. Resultant of two dipole moments working at an angle of theta as shown below. So one dipole moment is P, the other one is Q at an angle of theta. Then the resultant can be calculated by the formula resultant equal to under root P square plus Q square plus 2 PQ cos theta.